Let us discuss centroid of areas. So centroid of area means center of a plane. So let us define this definition. So centroid of area is the point at which the total area of the plane is acting. So let us define this. It is the point at which the total area of plane or lamina is acting. So this is the definition of centroid of areas. So it is the point at which the total area. So we have to remember it is the area, total area. The total area of a plane or lamina is acting. So now we know the planes will have area. So two-dimensional planes will have area. 2D planes will have areas. And one thing we have to remember, the planes will have only area and they will not have any volume, mass or weight. So simply they will have only areas because they are two-dimensional. Now let us see the formula for the centroid of area. Formula to calculate centroid of the area, that is x bar equal to a1 x1 plus a2 x2 plus dash by a1 plus a2 plus dash. Now similarly the formula for the y bar, a1 y1 plus a2 y2 plus dash by a1 plus a2 plus dash. So this is the centroid formula. So centroid means simply calculation of x bar y bar. So when the question is given to calculate centroid, what do we have to calculate? We have to calculate x bar y bar. And this is the formula for x bar and this is the formula for y bar. Now let us discuss the center of area with the help of a simple example. Let this is x-axis, y-axis. So there is some area. Let us take this is the area. So it has a center. From center of this diagram along x-axis, this distance is known as a x bar. Then from the center of this area along y-axis, this dimension is known as y bar. So it may be any area. So like planes will have area like a rectangle. So let us see the areas. Areas like rectangle, triangle, circle, semicircle, quarter circle, etc. So these are the areas. So let us take some area up to center of this area parallel to x-axis. This distance is x bar. Then from the center of this area parallel to y-axis, this is y bar. Now these are the formulas for the x bar and for y bar. So using these two relations we can calculate x bar, y bar. Now let us see the centroid of standard figures, that is centroid of areas. So this is the rectangle and the formula is that is x bar and it is y bar. So x bar means it is b by 2, y bar is d by 2. We know area of the rectangle, that is B into T. So similarly for the triangle, its base is B, height is H. So let this is the center of triangle and this length is X. So this length is B by 2. Then this is Y bar. This Y bar is H by 3. Now the area of the triangle is half into base into height. We know that. Then if you take the right angle triangle, it is slightly different. So let us take a right angle triangle and this is the center of this. This length is X bar, which is equal to B by 3. So for the equilateral triangle or isosceles triangle, X bar is B by 2. Whereas for the right angle triangle, this X bar is 1/3 of the base. Then Y bar is same for both the cases. This is the circle. Let this is X axis, Y axis. X bar is the distance from Y axis. X bar is the distance from Y axis and it is parallel to X axis. So this distance is radius. So similarly, so this is Y bar. It is also equal to radius. Now what is the area of the circle? It is pi r square. Now for the semicircle, so this is the X bar, that is equal to radius, and this is Y bar, that is 4r by 3 pi is the formula. So this is the new formula we are getting. So this is the different one. So you have to remember this. That is 4r by 3 pi. Then we know area. This is half of the circle. So pi r square by 2. Now similarly for quarter circle, we can calculate X bar Y bar using these formulas. So this is the formula for X bar, that is 4r by 3 pi, and this distance is Y bar, it is also 4r by 3 pi. So for the quarter circle, both X bar, Y bar both are same, that is 4r by 3 pi. So here also it is 4r by 3 pi. Now the area of the quarter circle, half of this semicircle, or 1/4 of the circle, that is pi r square by 4. Then the another one is circular sector, means a portion of the circle. So if you see the circle, let us take some sector, means so this part is a sector. So this is the circular sector. This length is the radius and this angle is alpha. This angle is alpha. This is X axis and it is Y axis. Now this is C is the center of this circular sector. Now this X bar, that is, I'll show you in the diagram. This length is X bar. So that is 2 by 3 r sin alpha by alpha. Whereas Y bar is 0. Now area of this circular sector we can calculate with the help of formula, that is alpha into r square. So these are the formulas we have to use for circular sector. Now let us take a problem on centroid. So that is centroid of composite figure. So when the composite diagrams are given, how to calculate the centroid. So this is an example for that. So this is the problem given. First I'll read the problem. Locate the centroid of T section whose flange means this top one is known as a flange. So this is called flange. Flange is 10 centimeters into 2 centimeters. So 10 centimeters is the length of this, 2 centimeters is the height of the flange. And web. Web means this part is known as a web. So web is 3 centimeter into 15 centimeters. So 15 centimeters is the total height of this, whereas 3 centimeters is this dimension along length. So this is the problem given. Now he is asking to locate the centroid. Means we have to calculate the centroid. So sometimes the question may be without diagram. So this they will mention flange dimension and web dimension. So we have to draw this diagram ourselves. Then we have to solve the problem. So let us solve this problem. See, we don't have centroid formula for T section. So that's why we will divide the given diagram into known planes. So if you divide this T section like this, so we will be getting two rectangles. So we know formula for the rectangle, so that's why I will divide the T section into two rectangles like this. Now let us take this top rectangle and this is the bottom rectangle. So let us give the numbers. This is rectangle 1, rectangle. Now let us take the reference axis. So I will take this as the x-axis, whereas this vertical line which is drawn from the center of T section as a y-axis. Now we know formula for centroid of area. So first I will write the formula. X bar equal to A1 x1 plus A2 x2 by A1 plus A2. So this is the formula for x. Then similarly y bar A1 y1 plus A2 y2 by A1 plus A2. So this is the centroid formula. We know centroid means we have to calculate x bar y bar. So let us calculate areas. A1, that is, so 10 centimeters this dimension into 2 centimeters. So its value is 20 centimeters square. Now A2, so this we have given number 2, so that's why I will write this as 2. Now A1 is the area of the rectangle 1, so that is 3 into 15. So that is 45 centimeters square. So these are the areas. A1 is the area of the rectangle 1, that is 15 into 3, 45 centimeters square. A2 is the area of the second rectangle, that is 10 into 2, 20 centimeter square. Now whenever the centroid problem given, first we have to check for symmetry. So if it is symmetric about x-axis or if it is symmetric about y-axis, then the x bar y bar values will be different. So the given T section is symmetric about y-axis. So I will write that given T section is symmetric about y-axis. So when the diagram is symmetric about y, symmetric means from this y-axis, this right hand side diagram is same as this left hand side diagram. So two halves are similar, then we say it is a symmetry. Now this given diagram is symmetric about y-axis. So we have to calculate only y bar, whereas x bar will be 0. Because if we take this as a center of rectangle 1, x1 will be 0, and let us take this is the center of rectangle 2, x2 0. So both values will be 0. x1 is 0, x2 is 0. So total x bar will be 0 because of this symmetry. So remember, whenever the diagram is symmetric about y-axis, you will get only y bar. The other value will be 0. So that point you have to remember. So x bar is 0, so we have to calculate only y bar. So to calculate y bar, we need y1, y2. A1, A2 we already calculated, just we have to calculate y1, y2. So let us calculate y1. So y1 is the distance, I will show you in the diagram. This length is y1. And y2 means from the center of second rectangle up to x-axis. So any distance we have to measure from reference axis only. Now in this case, this is a rectangle. So total height given as 15. Up to its center it will be half of the 15. So y1 will be 15 by 2. That is 7.5 centimeters. Now similarly y2 means this distance. So we know up to here it is 15 and this dimension is 2 by 2 means half of this 2. So total 15 plus, we know this dimension is 1. So 15 plus 1, that will be 16. That is y2. So y2 can be calculated as 15, this length is 15 plus, this is 2, half of the 2 means 2 by 2. So that equal to 16 centimeters. Now substitute all the values in this. So x bar is 0. Then so substituting all the values in y bar formula. So I am getting y bar as 10.11 centimeters. So this is the answer I am getting. Now the answer is x bar comma y bar is the centroid of given diagram. So x bar is 0, then y bar we are getting as 10.11.